In this video, we will discuss problem based on angle-launched projectile. Let's start with question 54. For a science fair competition, a group of high school students built a kicker machine that can launch a golf ball from the origin with a velocity of 11.2 meter per second and initial angle of 31.5 degree with respect to the horizontal. We need to solve question A to D. So let us first write down what is given to us. We have the initial velocity v0, which is 11.2 meter per second, and the angle theta, 31.5 degree. Now, since this is an angle-launched projectile, here the velocity will have two components, vx0 and vy0 initially. First part of the question is asking us where will the golf ball fall back to the ground? Where will it fall back on the ground means we need to find what is the range R. So in part A, we find the range R as V squared sine 2 theta over G. That is equal to V is 11.2 squared sine of 2 times theta. So 2 times 31.5 divide by G, which is 9.81. Whenever we are using a rule, we don't need to take G as negative because while deriving this rule, we already considered G to be negative there. So in this rule, I will just take the magnitude. No need to put the sign. When you solve this, you get the range to be equal to 11.39, which you can round off to 11.4 meter. Then in part B, they're asking you how high will it be at the highest point of its trajectory. So in part B, I need to find the height h, which is given by y0 plus v0 squared sine squared theta over 2g. Now, since we are starting at the origin, the initial y value will be 0 because we are starting from ground level. Then we substitute y0 is 0 plus v0 is 11.2 squared sine of 31.5 squared over 2 times 9.81. And when you solve this, you get the height to be 1.745, which you can round off to 1.75 meter. Then in part C, they want you to find what is the ball's velocity vector in Cartesian component at the highest point of its trajectory. Now at the highest point, the y component of velocity is 0. The only velocity component you have is the x component, which is constant, which does not change throughout the motion. So when I write the velocity vector, we can write v bar as vx x cap plus vy y cap. But at the highest point, this y component will become equal to 0. So you're only left with vx x cap. And how do we find this x component of velocity? In projectile motion, the x component of velocity remains constant. The acceleration along x-axis is 0, therefore Vx does not change. And since Vx does not change throughout the motion, whatever value of velocity we had for x component at the beginning, it will be the same value at any point in motion. So Vx would be equal to Vx0 x cap. We can find the initial x and y component of velocity as x component is v0 cosine theta, y component as v0 sine theta. So I will substitute for the x component here. Vx0 will be v0 cosine theta x cap. Let's substitute the value 11.2 cosine of the angle 31.5 x cap. That gives me the velocity vector to be equal to 9.55 x cap meter per second. And the same thing you can write in component form. You can write V bar to be equal to x component as 9.55 by component 0. We do the same thing for part D. In part D, they are asking you about acceleration. We know in projectile motion, the x component of acceleration is 0, whereas the y component is acceleration due to gravity, which is negative g, which is negative 9.81 meter per second squared. So if I were to write the acceleration vector, I will write it as a bar equals ax x cap plus ay y cap. Since ax is 0, you're only left with negative gy cap or negative 9.81 y cap. This is the value for acceleration. If I were to write this acceleration in component form, you will write a bar equals 0, negative 9.81. Now let's solve another similar problem. A ball is launched from ground level at an angle of 60 degree above the horizontal at 12 meter per second. Calculate the following. Part A of the question is asking you to find the initial vertical velocity. So let us first write down what is given to us. I have the initial velocity, which is 12 meter per second, and I have the angle theta, which is 60. And if we sketch the problem, we can draw the ball being launched with initial velocity at an angle theta and show the parabolic path of the ball. This velocity again we will split into two components, initial x component Vx0 and initial y component Vy0. You can calculate the x component by multiplying V0 with cosine of the angle theta and y component by multiplying V0 with sine of the angle theta. The first part of the question is asking me to find the initial vertical velocity. Vertical means velocity along the y-axis. So I need to find Vy0, which is equal to V0 sine theta. Let us substitute V0 is 12 sine of the angle 60. That gives me Vy0 equal to 10.39 meter per second, which you can write as 10.4 meter per second. Then we go to part B. In part B, they are asking us to find the time it takes to reach the maximum height. So we need to find the time it takes to reach only the maximum height, total time it took to reach over here. Now we know for a projectile whose initial and final y value is the same, we can find the total time of flight t by using the equation 2v sine theta over g. But this is the total time of flight, means the time for which the projectile is in air. If I want to find the time it took to reach the maximum height, which is halfway through its trajectory, I have to divide the total time of flight by 2. So I need to find basically t by 2. We will call this time it took to reach the maximum height as time of ascent, TA, and we will calculate TA as total time of flight by 2. So it will be 2v sine theta over g divided by 2. You can cancel this 2 off and you're left with TA equals v sine theta over g. Now substitute. V is 12 sine of the angle 60 divided by 9.81. That gives me the time it took to reach the maximum height to be equal to 1.06 seconds. Now in part C, they want me to find the total time of flight. So total time of flight, we already have this equation. I will use t equals 2v sine theta over g, which is 2 times 12 times sine of the angle 60 over 9.81. That gives me the total time of flight to be equal to 2.12 seconds. You could also calculate the total time of flight by multiplying this time of ascent by 2, because we already know the time it took to reach the maximum height, which was half the time. I can just multiply this by 2 to calculate the total time of flight. Now in part D, they want you to find the horizontal component of velocity. Horizontal component of velocity, they have not mentioned at which position, because it is going to be the same throughout. So whatever initial horizontal velocity you had, Vx0, it is going to remain the same throughout. So I can find the horizontal component of velocity Vx0 as V0 cosine theta. So V0 is 12 cosine 60. That gives me the horizontal velocity as 6 meter per second. Now the final part of the question is asking you the horizontal distance or the range the ball moves. So part E wants me to find the range R, which is V squared sine 2 theta over G. Let's substitute. V is 12 squared sine 2 times 60 over 9.81. That gives me the range as 12.7 meter.